Okay, welcome back. We're trying different things with the format of this thing. We're bringing back in the webcam, and at least for a little while. I took it back off because I didn't like the fact that it was covering up so much of the screen. And uh, in any case, welcome back to our ongoing project of XLR to USB converter. I'm Rich, and I hope you've been enjoying it so far. Today we're going to get into something a little bit kind of moving forward rather than just creating parts and stuff like that. We'll be simply creating the first parts of the actual schematic. So we're going to move out of the library editor for a while. We've got plenty more parts to make. There's probably a good half dozen more to make, but they're going to get more interesting than just making resistors and capacitors. There will be an inductor that we'll have to make here in a little while, but not today. Today we're going to just simply create a very straightforward little portion of the schematic, the title block of the schematic, and the beginnings of the compressor that we made in the very beginnings of the project here. We're going to start to lay down the passive components necessary to do that. So hopefully this is fairly short. You know, the other ones were pretty long, and tried to prune them down, but it just simply takes that long to make a part, and there wasn't much to fast forward through that. Especially that second one. So with that, let's get to it. All right, when we left off, we have we'd completed the last round of the capacitors, and so we have a pretty good selection of components: capacitors, resistors, a ground, and then this compressor. And that's what we're going to focus on right now, is the compressor portion of it. So to create a new schematic in Eagle is very easy. You just right click and say new schematic. Okay. And it popped up something off screen, which here it is. And we're now ready to, we need to pull up the data sheet in order to know how we're going to wire this thing up. So let's have that guy handy as well. This guy should look familiar. We used him quite a bit as we were creating the initial components, and we will use him even more so today. What we're going to be working with is there is an example schematic that tells you quite a bit about what to do here. That's built into the data sheet. So there it is. We're going to use this basic schematic, and we're going to follow it pretty much exactly as it is. How we plug things in and out is going to be, finishing up the circuit is not going to be today's task. When you start out with the schematic editor, you end up with a big blank sheet of nothing. So one of the first things we want to do is we're going to add our title block to it. All right, we spent a little time copying and pasting that back in a previous episode. And in order to add something from a library, we have to first make sure that that library is selected. So in the Eagle control panel, you just make sure that first of all, that your project is selected with a green dot, so you're working with the current project. And secondly, that the library we created before was selected with a green dot. If you are one of the people who are importing in multiple libraries, the Eagle built-in libraries or something like that, those must be selected as well. But like I said, I like to use everything from a single base library for that project, and then we'll just copy stuff in. So let's begin to do that. In order to add something from the library, you can either use this icon here, which I know the look of the modern Eagle 8.5, I think we're on right now, is a little different. But the ordering of things is largely the same, and certainly the icons are close enough. I think they kind of did the graphics a little slicker, but the tooltips that pop up that say add is the same, and the command bar up in the top is the same. So I can just type the word add, or I can click it. Uh-oh, it didn't like one of my libraries, so I've got an extra library that I can drop now. So my SDI foo, which is where I got my title block from, I don't want that anymore. I could look at my Eagle control panel and see that SDI foo is a project, SDI is a video standard, and so this project for some reason had been selected. So I can deselect him that way from the control panel, and that's fine. Also, in that same dialog box, when I used add, there's a button called drop, which drops that from the thing, and that's the equivalent of doing the same thing. So here are my libraries, of which I'm only using one now, and I click it down and I see all the parts, all the devices that I've created. Right. So we're going to start out with our compressor, because that's kind of going to be the, I'm sorry, we're going to start out with our title block because we don't have anything on our thing yet. Now this was an 11 by 17 title block that I imported. If you've created your own, you'll obviously be different. But we're going to put it so that its bottom corner is at the origin. I only need one copy of it, and so I'm fine. Okay. And you can see that right now the project is called Untitled because I have not saved anything. That's the name of the thing. And the date is not saved, and the sheet name is nothing, but the sheet has been filled in. So these were all macros that you might remember, and the only one that was custom for us is sheet name. So you could lay out your thing. I've got a couple of different title blocks that I use. So let's go ahead and save it, and we'll call it XLR to USB and give it the same name. And now, it didn't do anything until I mouse zoomed. I believe the new version of Eagle will pop that up right away. So cool. Now let's give this a sheet name. And sheet name is a custom attribute, which means I can do it in a couple of ways, right? But I have to select the title block as a part. So I can either go to its origin here and right click and say Properties, and I have these attributes, or I can take and hit the Attribute button and do that. That has an editor, which is what we want, and lots of other things. So right now, we're going to just edit sheet name. So you see I had two of them on there. I'm not going to mess with Do Not Bomb because I don't want to change that, but I do want sheet name to change. And the sheet name will be Audio Compressor. Now you notice a couple things pop up. One is that it's not equal to the default anymore, and the other is don't worry about the display thing because that's already been taken care of in another area. By putting a text object when we created the thing and calling it that, we have effectively put the attribute on the screen. It's just Eagle doesn't know about it, so don't worry about that guy. Okay, and there it is. My sheet name is Audio Compressor, and every time I create a new sheet, I will put another one of these title blocks in there, and I will change the sheet name. So I didn't change anything globally. That attribute is attached to that title block. Okay, so cool. Let's add another part. Let's do it from the command line this time. And no, let's do it from the other. We'll just do add. Okay, and I'm going to add my compressor. Right, that's going to be kind of the guts of what this page is all about. And as I hit escape, it popped that dialog back up again to say, do you want to add some more parts, right? So I've got a handful of stuff to do right here. Now, one of the first things I'm going to do is add my ground. But I'm going to do it in kind of a strange way. Well, no, let's go ahead and do that. So I'm going to add a ground symbol, and I'm just going to do it by typing it. Ground was the name of the part, so I can just say add by its name, and off we go. And for those of you who may remember how unhappy I was with the shape of this thing, that's why. Okay, so we've got a couple of things that are already ready to go. Let's look at our schematic a little bit more, and I can see from pins, pin 1 has a ground. I'm not going to worry about wiring them up just yet. 2 to 4 have a 10 microfarad capacitor, so add capacitor doesn't work because I didn't call it that. So, and I forgot what I called it, so let's go back. Now you notice when I hit add, something weird happened, right? Where are all my parts? Well, when I typed in add ground, I put that's equivalent to putting a filter in. So I just need to take that filter back off. And now I have the full list at my disposal. So non-polarized capacitor. But I can't just do that. I need to pick one of them. So I'm going to pick an 0603 size because that's the size that I like to use the most. And if I did my job right, which I of course did, because I'm totally awesome, then the part that I made was small enough to fit right in between that. And that's a combination of me being awesome and also kind of knowing that these two parts were going to be close together. So, and I'm going to put this capacitor in between, so we might as well give enough space for that thing to go in there. That way I don't have to have the wires bending around in a strange direction or something like that, right? So like that. Okay? So cool. I'm not going to worry about its value, and you can see its dielectric is mistyped. So that's what we call a happy accident. Remember I said I wasn't going to get into library editor? I'm going to have to get into library editor to fix that. There is a problem with this symbol, and if you notice, there's a spelling error. The macro that I used is misspelled, which means when I created all those parts and gave it a dielectric of, you know, X5R or tantalum or whatever, it's defining a macro that's not this name, so it doesn't know what to do, so it just prints out the macro. So let's go ahead into our library editor for just a second, and we'll pull up the symbol. This is a problem with the symbol, not a problem with the part. Cap NP was the offending symbol, and there's my my problem. Okay, change text. Come on, where are you? Probably in with the T's. Dielectric. That looks right. Okay. If we did our job right, that is almost all I need to do. But just to be sure, let's pick a particular non-polarized capacitor and see dielectric. That looks right. Looks like I spelled it right this time. So good for us. Now, Eagle caches libraries. So once you've created a library and then used it, and dropped components on it, it's okay if you add new stuff to it. You don't have to do anything special. You can begin to use it right away. As soon as you hit save on the library, it's good to go. But to update something that already exists is a little bit different. So what you have to do is you have to say tools, library, update. Don't use update all. I don't know why that doesn't work the way that I expect it to, but it doesn't. And say update, and then pick the specific one, right? So this one is the XLR to USB. It's in the board area, and there's the library. Okay, and now it updated it right like that. So X5R was the dielectric. The spelling error has been fixed, and there we go. So we all learned something that you'll need to know, because we will make changes to libraries as we start to use it. We decide we don't like the shape of the symbol or something like that. So okay, good. So we've got that. We did this guy. Let's hit a couple of more. I want a coupling capacitor on the input side, which is pin 5. And I'm gonna cheat a little bit, and I'm just gonna say I'm gonna copy this guy, because I'm gonna use the same size one. And this will give me an opportunity to play with a couple of other functions in here. And one you've probably heard me talk about before, called smash. So before I do that, let's go ahead and set the value of that other guy. This guy here, they recommend 10 microfarads, and so that is what we will use. So we say value, use the value field, 10U. I don't need to put 10 microfarads or any of the other stuff like that. This guy here is going to be, because he's the input coupling capacitor, 0.1U. So I could call, I don't like decimal points because they're hard to read sometimes, especially in these smaller ones. Remember, I used the smaller font on this one. So I'm going to say 100N. 100 nanofarads is 0.1 microfarads. So cool. All right. Now, I said we were going to do something called smash. This is the command called smash. And what happened was, when I made this part, I oriented the text in a certain way, and I positioned it relative to the center, so you can see all those attributes move with it. Smash lets you decouple those, and now each piece of text has its own origin, which allows me to move them individually. Now they're still linked together. It just allows me to reposition them a little bit, right? So a sideways cap looks kind of stupid with all of its text sideways and stuff like that. So I'm going to In fact, I'm going to say I don't care about the size layer at all, the packages layer. I just don't care. And that allows me to do this fun thing. Alt key. It's a good one to have. So what I'm doing is I'm right-clicking to rotate, and then I use this flip command, which means something different when you go into schematic editor or into layout editor. So beware that it doesn't do the same thing. But it's basically setting up the origin of these kinds of things, right? Come on. So lots of information that I like to keep on my schematics, you know, but that's the way. Okay, and you know, who knows? Maybe I'll even get I don't know, a little nuts with this thing. Still playing with what I like, right? So sure, that looks good, right? That's got all the parts on it, and there's kind of, I was trying to tuck things out of the way. So we got that one done. So that one in the bag. Number 6, pin 6, which is the averaging cap. Okay, now that's a polarized cap. They wanted a polarized cap. Why? Because it's a high value cap. This one probably should have been polarized too. But it's good. We'll do what they say. So add this time a polarized cap. And I'm going to use my, I like my tantalums, so I'm going to use that. Okay. Look, we have the same spelling error. Fortunately, we know what to do. I know why it has a spelling error, right? Because if you remember when we built that, I copied and pasted it. So the symbol for a polarized cap. Change text. Dielectric, spelled properly this time. Saved. Library, update. And there it goes. Now it's a tantalum. So good for us. I can also, if I don't feel like typing the word add all the time and running into that filter thing that happens, I can add my stuff that way. What else we got on here? Another 10 microfarads. Oh, let's set the value of this so that that's done. Okay, 10U that way. And the same 10U that I needed for my average cap on pin 6 is the same one I'm going to use on pin 10 as VDD. So, you know, that means it's just an easy copy. I'm using the middle mouse to flip the orientation. You can see up here that the thing changes just to get my text kind of in the direction that I want. Boom. Need a ground. Since I'm still in copy mode, no problemo. I'm going to run into the problem where these two touch each other. Okay, now output is free and clear. Output needs another one of these polarized capacitors, and he's sideways, so it's another opportunity to use the smash command. Set it sideways, smash. Eagle has some strange words for a couple of things there. Smash and rat's nest and a few other things like that. So, you may have noticed this before. When Eagle gets confused because you're too close to two things, it'll highlight the one that it wants to use. So if you ever click on something and it turns a really bright color and you don't know what it's doing, it's asking you, do you want this one or do you want something that's kind of close nearby? So it's trying to help you out. I'm going to give this guy some space. I'll kind of stack him a little vertically. Alt key makes everything better. Okay. So now I've got a couple of orientations, which is nice because that means I don't have to screw around and smash things. I can just copy existing ones. Let's start tackling some resistors. Pin 3, the shutdown pin, has a resistor on it. which looks like is a pull-up resistor to our power supply. So that's going to be a vertically oriented resistor. So add, oops, wrong program. Add a resistor. And I'm going to use these 0603s because I like them so much. Now this is a kind of a judgment call as to how you want to make it. I generally make pull-up resistors point up and down like this. And I'm already thinking that I may not like the exact way. Oh, that's right. I had 2 layers turned on. I don't want the power layer. I see that they are still on top of each other, which means, once again, we have a library problem. Shouldn't have made promises like we're not going to look at the library. So, change layer power. And which one? Nope. So that's what I meant by highlighting. I clicked on the origin for both sets of text was in the same spot. So it originally highlighted package, and then I was like, nope. So I right-click, and it moved to the next one. Power. Is that what you want? Yes, that's what I want. Save. Library update. There, finally. Okay. And package is not set right. So why not? Change layer package. Also, it doesn't look like that macro was set, which was strange, because I bet you know what I bet you it is? I called it size, didn't I? Size. So let's just fix it at the symbol, rather than redoing all those. Change text. Package is now going to be called greater than size. Save. Library update. Hey, that's what we're looking for, right? Because now I turned off that package layer. Turn it back on. 0603s all around. Okay, good deal. So now I've got this R1 who's hanging out, and he looks stupid because all of his stuff is oriented in strange directions. Smash. And I could have just said smash R1, and it would have just done that. It's still in smash mode, so I use semicolon, or I use the stop key, or you hit the escape key to end that. But for right now, we're going to set our value so I can see it. And the value is 500K, which I think is a little bit big, but yeah, we'll see. Let me turn on my power and package layer so that I can move everybody in smash mode. Kind of regretting putting that power macro on there because I don't think I'll ever use it, but whatever. Got the space. Okay. So there's that. I no longer need these power and package size guys. Okay. And you see I end up with a little gap. Oh well. I'll live. Alright, so that was on my shutdown pin, so I'm actually kind of located in the wrong spot. I want him to be over here. And you notice I haven't wired anything up yet. I'm going to get to that in just a second because I want to get all the parts here and then explain a little bit about what wiring actually means. Similarly, gate and compressor are all pulled up to VDD, and so I want to kind of have these vertically oriented as well. So I'm just going to keep these guys and just dead copy them. I could, you know what? I'm thinking better of it. Delete, delete. So I did a copy, which meant I kept all that smash stuff in there. Instead, I'm going to do and add a new instance of the resistor. There's a way to unsmash things too, but whatever. Okay, so I didn't like the way that that thing was going, and so now the question is, what are those two values? And we're going to have to look that up later on in the data sheet. Well, now's a good time. Might as well. We're working on the compressor. We might as well set up what it is. So you have to dig a little bit in the data sheet, although it's not too bad. I think there's an example circuit, right? So here's my threshold at minus 54 dB volts, right? So remember, in volt mode, a dB means a factor of 10 is 20 dB. So 40 is 10 times 10, so 1/100th of a volt, right? So 10 millivolts. And then 55 is, you know, as you're getting down to 60 at about 10K or so, would be 1 millivolt. So that's anything below an average value of 1 millivolts would get muted automatically, right? So I'll start with 2K for the gate threshold, right? 2K. And I'm going to add a note as to where I found that. So I can just add text just like normal and say what was 2K? 2K was minus 54 gate at minus 54 dBV. Now I'm on a net layer and I don't want to be there. I want to be on the info layer. So boom, got a nice little note there. These are real handy because you'll forget why you made certain decisions as you're looking at the thing when you quality check it. You say, where the heck did I pick that up from? And then the ratio pin is the other portion of it. So I'm going to say that this is going to be kind of an aggressive ratio, right? So 3 to 1 on a compressor. On a compressor, what this means, this graph kind of tells you everything. For every dB coming in, this is how many dB go out, right? And this is average values in dB, right? So your RMS-ish kind of thing. So it's not the peak-to-peak voltage. They take the absolute value and convert it to energy, and that's the RMS value, and then average it over some time set up by this capacitor, the averaging cap, right? So if there was no compression, if this was a straight wire, you would have 1 to 1. For every volt that comes in, on average, a volt comes out on average. It's not a volume control, right? If it had a fixed volume control in it, the slope would be different, right? So if I bring down the volume by 10, then for every volt that comes in, I get 1/10 of that out. So this thing has a slope of 1/10, right? So it would slide more kind of this way. What a compressor does is it has a corner where it's normal and then it stops being normal, right? So what this is saying is, like, at 10 to 1, wherever the DE is, the rotation point, as soon as you get above that, for every dB that comes in, it brings down the volume. So it's kind of like you sitting there next to a soundboard with your finger on the volume fader, and as it gets above VDE, when it gets that loud, then you bring down the volume. And then as he stops being that loud, then you come back up. So if you were watching the little VU meters on your tape deck or something like that, if you're an old hi-fi system, you say, okay, I'm going to set it up at 0 dB, let it come through, and then as the needle pegs up into the red, then you bring it back down again. And as it gets out of the red, come back up. So that's what this ratio is basically how aggressive you are. How as it gets above the threshold, how much do you bring down the volume by? And 3 to 1 is not bad. That's my experience. I did sound professionally for a while, and in college and in high school, and as work goes by and stuff like that for a couple of companies and did rock and roll concerts. 3 dB is noticeable. It's not a bad thing either. It takes a lot of the sharpness out when you do 3 dB. So I'm going to start with 3 to 1. Sorry, I kept saying 3 dB. I meant 3 to 1. So 35K. Right, so change the value, 35K. Right, and again, a note which says when you copy, you have to hit it by the insertion point here, which is the little cross. change text. You say ratio at 3 to 1. Okay. What else was on that circuit that we need to work on? I got my gate, I got my compression ratio, I got my averaging cap. I need, it looks like a little output resistor, so grab that one. He's vertical, so I'm going to make him vertical. Okay, and change the value to be what he wants. 100K, 10U, 10U up here. Fine, fine, good, 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 good. Okay, the only thing that's left to do is grounds, and so let's do them. It's remembering who is a pull-up and who is a pull-down is always kind of fun. This one was a pull-down. That one's fine. This one is across those two pins. This is a pull-up and this is a pull-up. Now, one thing we didn't do, we have a power supply, right? We have one called 5 volts, but I don't want 5 volts because if you look at the data sheet, this thing is a 3-volt part. So I need to create a 3-volt one, but I'm not going to do it today because we've spent way too much time in the schematic editor, and so you know, I just don't want to do it today. So let's start wiring stuff up. Now, wiring stuff up in Eagle, and this is the most important part of Eagle. So if you learn one thing about Eagle, it's this. This button called wire is not wires. Wire should have been called line, because that's all it is. It's a drawing line. We used it to draw lines on silkscreen layers when we were creating parts. We will not use it to wire things up. We used it to wire up the box around U1. We used it to wire up the wigglies in the resistor symbol and all the other things like that. We do not make any sort of electrical connections ever with wire. Bad. It should have never been called that. Shame on you, Eagle. And yes, the new version of Eagle also calls it that. What you want is a thing called net. Net is an electrical connection. When we get into the circuit board layout portion of this, the board program, it will still not be called wire, and yet there's a thing called wire in there. It will be called route. That's where you lay down copper tracks, which are effectively wires. It is the worst portion of Eagle. It's the one thing that I know that they probably can't change because it's too much ingrained in everything, but it was a bad decision. The word line didn't appear anywhere else. It's not like that word was taken. Anyway, let's start making this thing happen. Get our schematic from the app board, or from the demonstration schematic up and ready to go. And we'll begin building stuff. So I'm going to take and start with C1 here. So I'm in net mode, and all I got to do is connect. That's it. That connection is made. It's very easy. Ground, no problem. Shutdown, no problem. Output, no problem. I'm going to do something strange here, and I'm going to connect up portions of VDD, but not all of it yet. So this may seem a little strange, but it's trust me, it's a learning experience. And I'm going to come back to that section. Not at the moment. Okay, we're getting there. We're getting there. This is my. I'm gonna leave some stuff hanging that we haven't connected yet, right? Because this circuit is going to get connected to other stuff. So if I want to end something, I just double click on it when I'm done. Okay. Let's simulate the fact that I had a power line, and I'm just going to leave it hanging up here. We'll build it some other day. And this one is also going to be like that. Okay. What did I do here? I created this net, and Eagle, you can use the eyeball command and look at down here in the bottom corner as I click stuff. and it says net $N$4. This one's $N$1, $N$2. $N$ means it's a net with an automatic name. They all have to have unique names, but doesn't mean that they have to be ones that are useful or important. So automatic names just start with $N$. Okay, this guy here has $N$5. Right, now he's going to go. This is pin 10, and pin 10, wherever he goes to VDD, which it. Oops, I kind of miswired that a little bit. I was going to demonstrate doing something cool, and I didn't quite get it. All right, I'm going to do something here. Okay, when what happened there is it popped up a thing saying this had a name, because when I created it, even though he was dangling out in space, he had a name. And this had a name when I was connected to the bottom, and I tore him up and stuff like that. Which would you like to be? Now, in my case, it doesn't matter here. These are both automatically named, so I don't care. Pick one. But now I'm going to do it here again, and I'm not going to connect it to ground. So let's pretend that there was a whole big circuit. Maybe it's 2 capacitors, because I need twice as much capacitance. We'll take this back out here in a second. Okay, so that's a legitimate circuit, but I haven't grounded it yet. I'm just wiring it. And the question is, what does the eyeball say that is? $14. Okay, whatever. Watch what happens when ground here, who's never been connected to anybody before, and by the way, ground has been getting names. All these other guys right here, ground, ground, ground. So when we created those things, those special pins, those special supply pins, we called them the supply type, right, when we created it in the library editor, the schematic editor. So as I connect things to it, the name ground is an explicit name. Anybody connected to that symbol must be called ground. So it's going to say, well, are you sure you want to connect $14 into ground? Because I got to call it ground. If you say no, it takes away your connection. If you say yes, then it becomes ground. And if you've been watching carefully, all of the grounds got highlighted when I clicked it with the yellow eyeball command. So that was the power of the supply line. Okay? And we will do something like that similarly with the power lines that we haven't built yet, right? So let's get rid of that extra capacitor that I don't really need. I will actually connect another capacitor next to it. It's going to be it's not on the schematic, but this is something I always do. Whenever I build something, I build a high frequency cap and a low frequency cap, but we'll get back to that when we do the power supply and stuff like that. So we'll finish up a couple of things by saying, all right, well, at least let's connect everything together. These were power supply lines, right? So these got pulled up to VDD. Shutdown got pulled up to VDD. But I haven't called them VDD, and I could name them that, right? If I want to, I can make it now. You also notice that it automatically makes a dot on things that are connected, and it skips the dot on things that are not. So these two cross each other, but they don't get connected. Some people say that's bad form to ever have them cross, but work with a complicated circuit, and you'll realize it's just plain unavoidable. I can also do the wire bend thing to kind of clean up R1 over here. When I move him, you know, he's kind of bottomed out right there, and sometimes I don't like just the look of that if I can help it. So I can move him up, but now it stretched that thing in a weird way. So I just go ahead and use the split or bend tool, and now I've got what I want. You know, it's stylistic things. I wish I could do it with C1, but I don't think I have anywhere to go with it. So okay, the last thing that we're going to do is we're going to make some labels, and labels are cool. Because they tell you, they give a name to a net that's there, and it automatically changes. So I'll show you what I mean. So first I went to that, and then I clicked a net, and it automatically populated it with the name and $11. And there's a couple of shapes you can put around there. Like I like the shape that goes around this guy. Okay, and this guy right here, and you notice it remembered that I wanted the shape, and I just used my flip command to flip it around. Okay. Now, $N$11 and $N$10 are kind of stupid names. So let's go ahead and give it a real name. I'm not going to click on that. I'm going to click on just somewhere else and say, oops, that was the value thing. Say name. And I'm going to call it audio in. And you can see it changed to audio in. And this one's going to be called compressor out. Okay. Cool. Now if I was to do something really slick and put these two with the same name, I will fix this later on, but it confirms. It says, hey, it was called this. Would you like it to now be audio in? Yeah, do you want to connect these? Yep. Cool. And there is a option that I don't often use because I don't like the way it looks. In the set, yes, in miscellaneous, and it has XREF on it. I'm not sure why it didn't turn on my XREFs. XREFs are cross references, and I don't know quite why it didn't do that. It should have made a /1 there, but it's possible it's set up to only be if it's on a different page. Anyway, those are handy when you have to chase these things down. You can say, by the way, audio in is connected on page 5 or something. I want to change him back. So I'm going to go back to the name thing, and I'm going to say, change it back to comp out, and I just want it to be this segment, not every segment, because I don't want to change the one on the left there. So I've just broken the connection between those two. So all we have left to do is create our power supply lead, which we will call 3 volts, V plus 3V or something like that. Okay. So our schematic is coming along pretty well. We've gotten through a few basic things. How to add a part, how to change a library and get an update from a library, how to smash parts, pull them from libraries, what the concept of supply nets are and supply pins were, and why they can change things and make your life easier, because obviously everything with that symbol should be a ground, right? And so on, and flyouts and attributes and things. And we learned the very most important thing, which is never use wire. Never, just don't even use it on the wire. I haven't really found a reason to, unless you want to draw some picture or make a little block diagram. But don't do it. And sure as hell, don't ever put that on. You know, you can do wire and pick a layer, and you could really fake somebody out by doing one of these. Yeah, see, it's don't be this guy. Don't ever do it. Boo on you. Use net. Net is the command to use. Alright. I hope that's illustrative. It went a little longer than I expected because of the changes we had to make. But that gets you through the very first part of our schematic. We say save. And there's everything that we need to go. And we will see you next time. Thanks.